Okay? No, I do not wait while you copy down the whole page. You do that on your own time. Yes, because I didn't record there. I know you can. I tell you that every day, and yet people still say, wait. People still take pictures of it. It's like, it's recorded. It's on YouTube. I know, click. I just can't imagine looking at a screen that isn't my phone, so I can't possibly do it. Same exact question here. The rectangle was 23 and 16, right? But Mr. Mars, I just don't know why I can't do better on your tests. I just don't get it. I pay such good attention in class. I never, ever take my eyes off your work, and I'm always listening to what you say for all 80 minutes. Said no kid ever. Except for the first part. I just don't know why I can't do better in your class. So, of course, the triangle or the rectangle started at 23 and 16. But the next line says the length was decreased by x. 23 minus x. The width was increased by x, so it was 16 plus x. And the area was 378. So, of course, area is L and W. So you multiply that together, you get an awesome trinomial. You bring that 378 over, and you get this trinomial, and then it factored. You didn't even need to quadratic formulate it, although I bet a bunch of you did. Oh. I like doing extra work and taking longer to get my answers, Mr. Myers. That way, I have less time to waste on my test and talk to my friends. So, of course, if x is 5 or 2, I come to here. 23 minus 5 is 18. 16 plus 5 is 21. 18 and 21. 23 minus 2 is 21. 16 plus 2 is 18. So both of those answers work. And they both give you the dimensions of the new rectangle. Now, the last question. What made that difficult? The decimal. Does anything else change? Of course not, except I also typed it in backwards order. Did I fool any of you into writing A, B, C? I hope not, because I'm pretty damn sure I said yesterday that it was reversed, and you should write it as A, B, C. I know. I just couldn't remember if I did that with your class, the other class, or both. And there, of course, is the answer. Now, when I do this, and I actually punch it into a calculator, I get a negative value as well. Why, is that not an answer? You can't have negative time. So that on the parabola, which is right here, exists. But in reality, you throw the ball out here and it only lands there. It never existed as a throw before I threw it. So there can't be a negative root. In reality, the path of the ball is this. From where I throw it up, hits the ground. The parabola that is representative of that, because the parabola does not draw real life, will go around here and down forever and ever and ever. No matter how hard I throw the ball, it's not going through the ground. So in reality, it's the red part of the parabola. In math class, it's the entire parabola. The thing that you have to do is take the math knowledge and apply it to real life. Okay? Okay. Now, this do what with it? Satchot, I'm confused as to what you're asking me. It's A, B, C, and you put it into the quadratic formula. No, I don't want to, never mind. I want to help you. I just don't know what to do. You punch this into your calculator. You do 14 squared minus 4 times that square root. You do the work. I'm not trying to sound frustrated, but I don't know how else to explain it to you. You do math. You're in frickin' math class. Just punch it in. Now, maybe I apologize. It's the end of the day, and I've had very frustrating classes today. Not you people. My other 3 have been difficult. Maybe I need to explain how to make this work on your calculator. If you can't do this in one shot, what should you do? You should break it down into bits. And you may have to write down some numbers. You may have to show work. Son of a bitch. Let's go. Where should you start here? Where should you start? You may want to add possible course language to the review today. Where should you start? Because there are other people in this class that want to know how I got 2.99. They just didn't have the cojones to ask. Where should you start? Making this get me my answer. Preston. Yes, of course. So, you will write negative 14 plus or minus the root of. What is 14 squared? I don't have it memorized, Mr. Myers. I'm sorry. I've been in your class for 2 years, and you told me to memorize it, but I didn't. So you punch that into your calculator. You get 196. Then you get to here and say, Mr. Myers, I can't multiply 4.9. That's crazy talk. What are you talking about? So you actually punch it into your calculator. Negative 4 times negative 4.9 times 2. And what do you get? You're going to get somewhere around 40 plus 39.2, because a negative times a positive is a positive, over 2 times negative 9 or negative 4.9 is negative 9.8. I would like to think that is doable in your head. Now what should you do? Now what should you do? I would add those and get the square root. What is it? What's that? It should be somewhere around 50 or 15. 15.3. Now, negative 14 plus or minus. Negative 14 plus 15.3 divided by negative 9.8. Or negative 14 minus 15.3 divided by negative 9.8. And there you find your answers. This one will be negative, won't it? So I don't care about it. This one will be positive. 14 plus 15 is almost 30. 30 divided by almost 10 is about 3. And we got an answer of 2.99. Now, ladies and gentlemen, I am begging you, if I ask you to do math without a calculator, you are weeping, crying, gnashing your teeth. Oh my God, I'll never pass this test. And yet, when I give you stuff that you have to use a calculator for, more than one of you, and I'm not picking on you, Satjo, more than one of you are like, what do I do there? You do math, guys. You've had 12 years of math practice. And some idiot decided you should get a calculator when you were in grade 2. Because, well, they'll always have a calculator in real life, so why don't we just let them have it now? Which, of course, has resulted in kids not being able to do any math. Because you have no confidence in yourselves. You tell me that you do, but I have oodles of videographic proof of me saying what's negative 7 minus 16 and having my entire class not know the answer. Until I say, go to your calculators. And then it all comes out. Even then, some of you get the wrong answer. So it's a good thing you've used calculators your whole life, yeah? Right. Please, at some point, right? You got to just try this stuff, man. It's written right there. It's just math. Okay? Stop looking for ways to not write stuff out and just write it out. And then you can't screw it up. Okay? All right. Now, I'm going to show you not a new method, but I'm going to give you a new tool to solve these. Everybody in the room, go and get a graphing calculator from there. If you have your own, use it. Even if it's not the exact same. Now, a bunch of those calculators have no batteries in them because kids are thieves. Yes. I don't know why. What in your lives use AAA batteries? Maybe your remote at home, but I'd like to think your folks pay for those batteries. Get one in front of you, even if you have to share. Here. I am going to put one of these calculators on my screen. You have seen me do this before, but I've only done it to show you calculator work. This time I'm actually teaching you how to use the machine. All right? So, everybody turn on your machine. You should be looking at a flicky gray light. All right? Listen to... I'm getting to it, okay? I'm getting there. If you are not looking at a blank screen with a flashing cursor in the top left corner, push clear. Is everybody looking at this screen? Then push second mode. Did that not work? Give me your calculator. I don't even know why I bother. It's not you. I have never even seen that be done. Yeah, you can do all kinds of stuff on these.
It was like lights up and it's just like charger and stuff, but you like download them too. Every time you finish
Oh my God. Okay.
I could just share with Chris.
Just share for now because it needs a full reset. All right, is everybody else looking at the screen that I am seeing or that I have? Excellent. Now, everybody push the Zoom button, then push 6, right top middle. Follow the bouncing pink circle. Zoom, 6, clear. And you should be looking back at this screen. Is everybody back at this screen? Excellent. Okay. Now, please allow me, do not mess around with your calculator right now. I wish for you to look at the screen. X squared minus 6x plus 8 equals y. Now that is a particularly easy quadratic formula, yes? Because it's factorable. So we factor it, x minus 4, x minus 2 equals 0, because we're looking for the 0, and we know x equals 2 and 4, right? Now we are going to use this question that you already know the answer to teach you how to use the machine, all right? So, step 1, everybody push this Y button. If you already know how to use these, I apologize. If you see anything written there, clear it. So you should be looking at a screen that looks like this now, yes? Everybody? Okay. This is recording both my voice and what is going on here. You can watch this later if you want. Oh, and before I forget, if you have an Android phone, you can get an emulator of this exact calculator on your phone from the Google Play Store. You won't be able to use it for tests, but you could use it in class. Now, we are going to enter this in here. All right, now notice it's already set up y equals. Y equals. Everybody's cool? Now, the first thing in there is an x. Now in math class, that x can be any letter, any symbol. Yes? But your calculator does not have access to the infinity of symbols that you might want to put there. Some stupid wingding or something, I don't know. Your calculator uses, see that button right there? X, T, theta, N. Right below the mode button. Does everyone see it? That is your variable button. No matter what the variable on the question is, the independent variable is that. So we hit X, and your calculator will give it an X. Everyone cool? Now that X is squared, so we hit X squared. See the button right there, down on the left, right above the log button. Square. Everybody's got an x squared now, yes? The next thing is minus 6. Do not hit the negative button. Hit the minus button. Minus 6 and then x. Yeah? And then plus 8. Does everybody have that there? Excellent. Now hit graph. And you have a beautiful parabola. Is everybody cool? Now, stop for a second. Surprise, surprise. What isn't the same, Manru? Did you push Zoom 6 at the beginning like I told you to do? Or were you talking to Harsh and not paying attention?
No, I did, but it has cleared enough.
This parabola is beautiful in that it is visible on the screen. Now, please notice, the axes that we have been given go from 10 to negative 10 and negative 10 to 10. This is called a standard window. Now, is it possible to have values that we may need to graph that are bigger than 10 or bigger than or smaller than negative 10? Yes. So we can adjust this window. Where do you think you would do that? Look at the calculator. There are 2 buttons that might allow you to change the view. What do you think they are? Window and not mode. We've already done it. Zoom. All right? When you hit window, ta-da, and you all already know what this means. The X min, that means the lowest X on your window right now is negative 10 because min means minimum. The biggest X on your window is 10. So you'll go from negative 10 to positive 10. The Y's, same thing. What do you think scale means? Yes, 1 dot right now is 1. I could change that to using the arrow keys like I was playing an old 8-bit Nintendo. I could change that to 10. When I change that to 10, how many dots will show up on my screen? 1, because it's 10 by 10 now, but each dot is worth 10. See? Only 10 and only 10. Everybody cool? So I'm going to go back. If you ever need to go back to standard, it's Zoom 6. And I'm back to normal. Everybody good? Now when I hit zoom, I have lots of options. I can zoom in, 2. I can zoom out, 3. I can zoom decimal. I can zoom square. I can zoom standard. Standard is a normal one, remember. But I find a very powerful one in Zoom is the Z box. When I hit 1, using the arrow keys, you will see that you will get a plus sign. Do you see mine right there? Everyone see it? I can't make it bigger. Does everyone see it? If I hit enter and I use the arrow keys again, please look at what I am drawing. See how I've drawn a box? If I hit enter again, watch what happens. I zoom right in specifically on what I need. Is everybody cool? Okay, play around and get a Z box right around what we are working on. So you should only see this. You need to push zoom and use the arrow keys or push button 1 to get to the Z box. Is everybody good? Is everybody good? 1 for the Z box, and then use the arrow keys to draw the box. If you have it, please help me and get the people near you to have it. Because you get it. They apparently don't. Okay, screw it. I've flown too close to the sun on wings of pastrami. Just hit zoom 6 right now. Just hit zoom 6. Just hit zoom 6 so you're back at looking at this. Just push Zoom 6. You have to push 2 buttons. That's it. All right. Now, we now have our graph, right? Now, when we do this work, we are calculating stuff about this parabola, yes? Well, now we have a calculator. Calculators calculate. Agreed? Everybody look at the blue word above the button that says trace. What does that word say? Calc. What do you think that's short for? Calculate. It's blue. How do you think we access the blue? Second calc. And observe all the things our calculator will do for us. We will only be using 1, 2, 3, 4, and 5. And almost never will we be using 1. What do you think we are seeking there? We are seeking zeros, indeed, because we are seeking the spot where x will result in a 0. Yes? So, we are going to either use our arrow keys to get down to 2, or we are going to hit 2. And that takes us back to our drawing. Is everybody back at their drawing? Does everybody see the words left bound? What direction is left? Towards the second function keys, yes? So I need a left bound. What do you think bound is short for? Boundary. Well done. I am seeking the value where x is 0, yes? So I must be looking at this graph. I need a left boundary of where I'm going to look. So do I need to be left or right of the point I care about? I want a left boundary. Where should I be? On the left of the point I care about, correct? Now, if you use your arrow keys, you will see a flashing cursor sliding down the parabola. There is mine. Does everyone see it? Right under the pink dot. Does everyone see mine? Is it to the left of the point I care about? Of course it is, because the point I care about is right there where it crosses. Is that flashing dot to the left of it? Yes. So what do you think I would push? Because now I have my left boundary in a good spot. I'm going to push enter. What does my calculator then ask? A right boundary. So now I must go to the right of that dot, yes? How will I know I have crossed to the right? Look at these numbers at the bottom. What is happening to the x and the y as I approach that dot? X is getting bigger. Why is x getting bigger? Because I'm moving to the right along the x-axis. Why is y getting smaller? No. Why? Because I'm moving down. How will I know when I have moved far enough? What will happen to the y value? It will, no. It will turn negative because now I am past the x-axis. Does everyone understand? Is my y value right now negative? Let's close some more blinds. Yes or no? Yes. So what should I do? I should push enter. When you have done that, what does your calculator then say? Yes. Now, why on earth would your calculator have to make a guess? No. Is every single number that we come across in this classroom an exact number? No. What is the square root of 2? It's not rational, is it? It's 1.414 for how long? Forever. So can our calculator give us an exact answer? No, so it's guessing. Now in this case, when I hit guess, it is going to give me an exact answer. Of what? Two. No, I didn't. Oh. And C, X was 2. Everybody with me? X is 2 when Y is 0. Now, all of you try to make your calculator find the other root. So it's still left boundary, right boundary, but we're looking at this root over here. So I'm going to hit second, calc. What do I find? 0. Now you use your arrow keys to get the 4. We know it's going to be 4 because we already did it, but go ahead. Remember, I'm on the left, so was everybody able to do it? Everybody able to do it? He waited patiently. Was everybody able to get 2 and 4? The calculator is telling you exactly what to do. Set a left boundary, set a right boundary, and then guess. You know it's the right boundary when you are to the right of the dot you care about, which means the y's are... What are the y values to the right of the right-hand root? Positive. Everybody good? Okay. Now, everybody has done it? Okay. Go to hit Y again. Clear what we've worked with. Now, remember that really difficult ball throwing question from the work? Right? It was H equaled 2 plus 14t, I think, right? Minus 4.9t squared. I think that's what it was, yeah? That's exactly it, yes? Okay. And it was a pain in the ass, wasn't it? All right. Well, wait a minute. I've got an H and a T. Isn't that the same as a Y and an X? So let's take this and put it over here. Does my calculator care about order? A, B, and C. Does it? No. 2 plus 14. Now, what do I hit? X minus 4.9x squared. Yeah? Everyone agree? Now, graph it. Now, some of you should notice something a little weird here. It goes off the screen. So if I wanted to know the height of that ball, this window is no good to me, is it? Of course not. Now let's stop for a second and think. I could zoom out. You're absolutely right, Sale. I could zoom out. That'd be good. But let me ask you this. I'm throwing a ball. Do I need any negative numbers? Why not? Doesn't go underground, doesn't go back in time. So I'm going to go into my window and I'm going to take away these negative x's because I don't need them. But if I put it at 0, it's going to put the x-axis right on the edge of the screen. We want a bit of room to work, yeah? So what should we make our minimum x? -2. Sounds good. Maximum x. Well, you saw on the graph, there was a lot of empty space out to the right, wasn't there? So let's make our x maximum 5, because we didn't need all that room out there, did we? 5. And our x scale is 1. That's cool. Do I need any negative y's? Have I thrown this ball so hard it's digging into the ground? No. But if I set it as 0, that line's going to be right on the edge of the screen. Do we want that? No. So what should we set it as? -2. Sure. Now, was 10 high enough? No, it went off the screen, yeah? Now, you saw the picture. It was almost there, right? They were almost touching. So do we need to go too much higher? What do you want to do?
15.
I'm going to go 15 because I like multiples of 5. Nothing personal, Priya. When I'm in the car and I'm turning up the stereo, I hate it when it's not at a 0 or a 5. I know it's weird. It's just a little thing I have. So I'm happy there. Now I'm going to push graph. Now look. Now we're in good shape, yeah? Now, we're intelligent people. Looking at that, we can see that this 0 is in the negatives, right? That's useless to us. So which 0 do we care about? That one. Let's go find it, shall we? Second, calc. 0. Left boundary. Please notice my cursor is already to the left of where I want it to be. Does it matter where I put it, do you think? Or is it okay as long as it's left? It's okay as long as it's left. Now, sometimes when you get a little further with these calculators, you're going to have 8 or 9 lines crossing over here. In that case, you want to be as close to the point that you care about as you can get. So I'm going to move it a little just to get in the habit of moving close to where I want to be. So I'm going to go ahead and move it. Now, my calculator is a real pain. The button doesn't work very well, so I got to do this button lock thing. And then it goes flying, and sometimes I forget and I talk, and I get back to it and I remember where it is, and it's at like X is like 5,000. So if you see me hit button lock and then start to talk, somebody yell at me. Or I got to do it coming back. And then I joke about how old and stupid I am, and then it goes miles too far the other way. So help me out here, okay? Am I left of where I want to be? And Y's are positive, so I'm okay? So can I hit enter? All right. Now, I need a right boundary. When do I know I can stop? When Y's are negative, because I will have crossed the x-axis. Is it negative now? Negative 1 point blah. So I can hit enter. I've set my boundaries and I'm happy. Calculator says, guess? And I say, why thank you, Mr. 84 Plus. Please guess. Enter. X equals 2.99. And what did we get when we ran the whole thing through our regular old boring calculators? 2.99. Aight? Everybody cool? All right. Now listen. You got 20 minutes in class. When you go to page page 88, you see there are 33 equations there. Now listen. We have 4 methods. 1, factor. 2, complete the square. 3, quad formula. And now 4, the GDC, graphic display calculator. I want you to do complete the square at least 5 times. When is a good time to complete the square? Even numbered B and no A. Right? Because when there's an A, we got to factor it out. It kind of screws us up. Okay? So there's at least 5. And for the graphing display calculator, because you can't show me work, I want a max of 8. All right? You got 25 minutes now. Not quite, actually a little less. Okay? Now, please notice something weird is going on with a lot of these equations, yeah? Are they set up nicely? So sometimes we got to move stuff around, yeah? Everybody cool? All right. Now, I'm going to pause this. I'm just going to do these 4. They'll be on the end of your video. So, ladies and gentlemen, there's the first 4. There's only like 3 minutes left in class. I guess I'll just keep going and add this to the end of your assignment or the end of today's video. No problem. If you have a calculator, please put it back up there. And of course, ladies and gentlemen, because I am doing this on the video, I will not be using the graphing calculator at all. But if you've used it, you will get the same roots I get.
GI-83s, yeah, that one. It looks the exact same, right? Okay.
Because I always know it's
Vai ser muito engraçado, porque foi como